The yesterday's generics topic. Okay, let me do the quick summary what we discussed yesterday. So we discussed about generics yesterday, right? If I want to write a method or code must works for multiple types, I can go for generics, right? So if I don't specify any type, that's called object, it's called raw type. So whatever you specify within the angle bracket is called parameterized type. So when I go for parameterized type, you will get a compile time verification, no need for downcasting, right? So those are the advantages. We have discussed about the concept of type eraser. Type eraser means the Java generic type is only available at compile time, but not available at runtime to get back the backward compatibility support. That's a type, type eraser concept. Then we have discussed some of the restrictions on generics. Can you remember? The first one is array subtyping is covariant, but generic subtyping is not covariant, right?
Intuitive.
Yes, intuitive. Then another thing is you cannot make your list string as a component type of array. That's not possible, right? So that we discussed. Another rule. What is the fourth rule? Component type is not or applicable. Then what will be the fourth rule? Anybody remember? Only three rules, right? Component type is not allowed and component type of array, you cannot do it. And we have discussed the concept of what is refiable and non-refiable type, right? So what is refiable type? Yes, once the information is available at compile time and runtime is refiable type, right? But generic is non-refiable, right? At the runtime, we don't have any type availability. And we have discussed about the wildcards, question mark externs and question mark super. So these are all bounded wildcards. So when you use question mark extends, you cannot add element into the collection. You can retrieve it. But when I use question mark boundary, you can, you cannot retrieve it, right? So these are the two rules we have discussed. If you don't want to work with any type, with any operation, the general go for unknown wildcard, right? So when I use question mark, sometimes we cannot capture the type. So we can write a helper method to capture the type. So this is what we discussed through the finding maximum example, right? So today we will be discussing about best practices with Java 8. So this knowledge is really important when you go for the future courses. Okay. Best practices in the world of object-oriented programming are a way of ensuring quality in code. Code that adheres to best practices tends to be easier to understand, easier to maintain, more capable of adapting in the face of changing requirements, and new future requests, and more reusable for other projects. This simple theme is reflected in individual life. There are laws governing life, both physical laws and laws pertaining to all kinds of relationship and interaction. When life flows in accordance with the laws of nature, life is supported for success and fulfillment. When awareness becomes established as its deepest level, action and behavior springing from this profound quality of awareness spontaneously or in accord with the laws of nature when you regularly practice TM. Okay. Here are the outline which we are focusing today. How to unit test the stream pipeline, because we have a chaining of functions, right? So how can I perform a unit testing? So that's what we are going to discuss as a first topic. Okay. Stream pipelines with lambdas in the mixed form of single unit. It is not obvious how to effectively unit test the piece of pipeline, right? I have multiple chaining of function, filters, maps, so many things I'm doing. So how can I test the pipeline? There are two useful guidelines. The first one is, if the pipeline is simple, we can name it as an explosion by using functional interface and test only that functional interface. Okay, that's the first step. So if you look at this code, then I'll come for the second step. I want to convert my input into uppercase. So what will be your requirement? Take the input and return a uppercase letter. So I can choose with the functional interface, right? So all to uppercase, whatever list of words you have, that's your input argument, dot stream, map to uppercase and collect as a result. So here, if you want to test the pipeline, just you need to test whether your code is converting to uppercase or not, right? So for this purpose, you no need to write a complicated logic for that. Just I can test only the map logic, right? So this is directly you can check it. So what I can do it is take a input of list, and this is my input list. I'm going to call this functional interface all to uppercase dot apply, pass the input. So this is your expected output, right? So I'm going to compare the result with whatever result it came from. This is my expected output, and this is your output came from your logic. So you can easily test this one. I hope you remember attest is for the, if you perform unit test, before the method you need to give attest annotation. So this is the straightforward approach. Any question on this approach? So whatever logic you perform, capture in an expression, just test, unit test that expression. This is your simplest straightforward method. Okay. The second approach is, if the pipeline is more complex, pieces of pipeline can be called from support methods. So you can test only the support method. Okay. So let's go to the next scenario. I want to sort a list of employees by first name in ascending order and salary in descending order. So how could we write this one? You have a sorting method. So we are taking an input of employee and return a list of employee. Okay. The requirement is stream your pipeline dot sorted comparator dot comparing by name, because my request is first name by ascending order. So we are going to call comparing by name, and then comparing by salary, but it should be in the reverse order. So this is your pipeline. So to test this one, it is easy to compare at least two objects are working finely or not, right? No need to check with the entire list. So instead of that, capture only this logic in a method and only test that method. So let's see this code how we did in library companion package. So here is your library companion class. It's like your Lambda library. We have a public static comparator method. So here is your logic, right? So what we are going to write it, I'm not going to compare the whole list. So if I test this pipeline, you need to pass a list of employees, right? I need. So what we are going to do it is, I'm going to compare only the two employees. If this logic works fine means it will work for all the inputs. So we are going to compare method. This is my method which takes two employee. I'm going to compare by calling this comparator. So we write a companion method here. By using this method, instead of testing list of employees, we are going to test whether it works for two employees. Okay. Any question on this one? I will show you the test code. Right now, this code has comparator type of object. One comparator interface is here. We write one method by passing two employees to check the comparative with this logic. Okay. Go to your test class. We have created three employees. First employee is Joe1, J2 and Zing with this data. So now if I want to compare, I need to check the logic is works or not, right? So instead of passing a list, I'm going to compare with two employees. So your library companion dot compare employee. So we are going to test this method. So this is called auxiliary method. We are writing a separate method for testing the code. So now I'm going to pass the first employee Zim and Joe, because it will be an ascending order by name, right? So Jim will come first, Joe will be next. So that's what this value is less than 0 means this will come as a first. Then we are going to compare Joe to and J1. So you know that when we want to write a test case, we should be a test. So I hope you know this one, because unit testing is covered in FPP. So if you want to create a new unit test class, right? So JUnit test case, open this file. Then before that you need to install a JUnit jar file in your project. So if anybody don't know that, I will give you a step-by-step implementation of how to use JUnit. You can contact me. I'll send you a file how to perform the setup of JUnit test. So if I create each test case, you should put add test. This will be your method is tested by the JUnit tool. Okay. So let's run this one. See here, it's not an application. It's a JUnit test. So once you right click, you can run as a JUnit test. So I have one test case I run, so I have no issue at all. So we have only one test method. If you have multiple test method, it will be 2 by 2 like that. Okay. So the complex piece of code will be captured in a method, and while you perform unit testing, just test the method. That's the idea. So here is the summary. The first 2 points. Right. If your pipeline is very small, just name it as an interface or functional interface and unit test directly. If it is complex, just capture the logic in a method. That's what we use a method reference is useful, right? Instead of writing a lambda expression, if I use a method reference, you can test only that method. Then automatically your map function will work. So that's what capture in a auxiliary method. Unit test only that method. If you have multiple lines of pipelines code. Any question on these ideas? That's what we did it using the library component. Just capture the code from the slide. Okay. So this exercise you guys can take a look at later. Okay. Now we are moving on to the next topic of annotations. So do you remember what kind of annotation so far you used in your MPP? Override. Functional interface. Then in JavaFX you use some annotation. What else? JavaFX project, right? At FXML, right? At FXML. These are all annotations, right? So that's what we are going to look more deep about annotations. Okay. So already we have seen, so right now we have seen add test annotation, add to override, add functional interface. Suppose any of the library is deprecated, we can use add deprecator. If I have any warnings, I can suppress by calling add suppress warnings. And also if you want to make a Java doc annotation, you can use add author since. These are all annotations, right? So let me open here, annotations. Annotation example. Okay, predefined annotation. Okay, we see several annotations. For example, if I remove this one, okay, let me put come on by one to show you. See, you will get a warning, right? The value of X variable is not used. So how can I suppress that one? By providing add suppress. Did you see that? So if I comment line this one, you will get a warning. To suppress this warning, we can use add suppress warnings, right? So this way we can use some annotations. And over here, when I create a list like this, right? So you will get a warning. What kind of list it is? It is a raw type, right? So when there are two annotations, two warnings here. One is it's a raw type and also it's not be used, right? So if I don't use it, it will give you two kinds of warnings. So if I have multiple values to warn it, what you can do it is inside this one, you can pass the values. So there are two kinds of warnings. I want to suppress it. One is unused, another one is raw type. So if I change it into a parameterized type, still you will get unused. So if I have multiple values, you can inside the warnings within this brackets specify what kind of. If you have only one, you can use by this way. If you have multiple values, specify by this way. But if I want to suppress everything, instead of doing each line, what I can do? All, which means whatever warnings from the suppress you get, everything will be suppressed. So these are the different way to use a add suppress. Okay. So now, if you see here, you will get a warning. What the warning is? That it's deprecated, right? So if it is deprecated means what you can do it is you can add a warnings before the method. Okay, so which is called add suppress warnings of, okay, I put all right. So add suppress warnings of deprecation that you should declare before the method. Okay, so this suppress warnings, so that's what I mentioned. Always add suppress warnings of depreciation should be before the main method. So there are some levels where I can use it before the method or before the class, before the field, so many types of annotation. Okay, so when I want to use deprecation, that should be before method. But when I give at suppress, I can give before the field, right? So like that, various levels where you can specify. And what are the others? Yeah, add deprecated. So this method is deprecated means before the method. So always add deprecated should be given before the method. Okay. What? Yes, that's what we will look at. Okay. Okay, so these are, maybe if you look at the author annotations from the documentation, so I'm going to see, look at array list. If you look at the array list API class, see here, we use @author. These are all the annotation inside Java documentation, right? So within this bracket is called documentation, right? Slash, char, and star slash. So whatever you specify is called Java doc annotation. Okay, so maybe if you look at, there are some annotations in this code or not. Let's see. Is there any? Okay. Okay, we'll look at parameters. So these are all annotations. Okay. Let's see some of the informations about annotation. The second point is annotations are the tags that are inserted in your source code so that some tool can process them, right? So when I use @override, what your compiler will process? If you change the signature from the parent, automatically you will get a error. So that's called processing tool. Some tool can process once you give the annotations. Okay, so that whatever source code you have, if you put some annotation, that are processed by some tool. So this is called as annotation tools. So it will verify where you place the annotations. So the benefit from the annotations you create, you need to select a processing tool. For example, @test, which is processed by JUnit. When I use @override, which is processed by compiler. So some of the tools you need to process the annotation. The best example is @test is processed by JUnit tool and @override is processed by your compiler. So some of the tools should be there. Okay. So annotations can be applied to your class, your method, or variable. Wherever you want, you can specify the annotations. Okay. You can create your own annotation also. And as we mentioned, annotations can take 0 or more elements. So if you look at here in this code, what the annotation will take a input of all, right? So over here, this annotation take 2 values. So your annotations can take some values. So that's what the next point is. If you look at that annotation, annotations may take 0 or more elements. So for example, @bug report is a user defined annotations, which takes 2 values. One is assigned to, another one is severity. So for the annotation, you can pass some values. That's the meaning of this point. Okay. So when annotation has just only one element, just you can give unchecked. The name of this value is equal to unchecked. If I have only one value, I no need to specify value equal to. Simply you can give unchecked. If I have multiple authors, so this from JDK8 version, but pre-JDK8, I think you have to specify @author 1, author 2 like that inside the bracket, different values. But from JDK8, you can use repeated annotations. So that's only possible from JDK8. If the annotation is same type, you can repeat it. So that's what if you look at the array list, right? So there are repeated annotations. If you see here in the documentations, right? See, at author twice repeated, right? At C, these are all many times. These are all called repeated annotation. You can repeat the annotation multiple times. So that's called 7th point. Okay, any question on these 3 points? Please take a look and read it. So we will discuss about how to create our own annotation. Right now, an annotation can take multiple values. That knowledge is enough as of now. Okay. So the next is you can create your own annotation. That's what we are going to talk about, how to create your own annotation. Okay, annotations are works like an interface. For example, we know add to override, right? Let me open add to override annotation from the API library. Okay, if you see add to override, it's an annotation. Okay, so if it is an annotation means you have to give an interface. All annotations are interface. But if it is yes, so you have to use the keyword at. If I don't give this keyword means it's a regular interface. I want to make this as an annotation means before the interface put at, then name of your interface. Okay, so for that example, we created our own annotation. Let me close. Keep this example of override. Okay, so we created annotations in, okay, bug report is an annotation. This is what we showed in that PowerPoint, right? So I want to create my new annotation. So what the term you have to use? At interface. Any question on this line? Then we'll go over the remaining step. If I want to create your own annotation, you should use this signature. At interface followed by your own annotation name. Any question on this line? Okay. Then as we mentioned, annotations can take a value, right? So how can I pass the value means it's similar like your method, how you declare a method. Okay, so that's what when you see here in the previous step, we pass assign to Hari and severity is equal to 10. So how can I pass these two? These two are specific like a method. So for that purpose, when I want to use assign to, it has to return a string. So if I don't give any value, by default, it will take this value. And integer severity, because severity I assign an integer number, right? So that's what the type is, return type is integer. And if I don't give any value, the default value is 0. Please look at this one. This way you can specify whatever values you want. Okay, let's see the suppress warnings. I don't know, can we open, because it has some values, right? Suppress warnings. Okay, let's see suppress warnings. Okay, here is an interface because that's what we specify, multiple values. So that's what it declares as string value. So the same way you can create your own annotation. It takes two values. Okay, any question on this part? Okay, so now you should specify these two things. One is retention policy, another one is element type. Let's take a look at what is this one. Okay, so go to your slide. When you specify these annotation, you must specify at retention as well as at target. These are the two values before the annotation you should specify. So that retention may be a source level or class level at runtime. So if I put source level means your annotation is retained by the source level and it's ignored by the compile. Okay, so your code is processed in your source code level. Okay, but not at compile time. Okay, that's an example. These are all a type of retention policy dot source. So when you look at suppress warning, what the level they give it is. If you see suppress warnings, Suppress warning when you open here. So what the returns and policy they use? Source code. So only source code level we can use it. So let's see how to override. So what the returns and policy they use? Source. So like that, we need to specify the retention. What the retention policy is? 3 categories: source level, class level, and runtime. Okay. The first one is source level. The class level, if you provide, the marked annotation is retained by the compiler at compile time, but ignored by the JV. So one example is at nullable interface. We haven't used it. So this is a one example of this category. So let me open at nullable. Okay, so it's a class level annotations. So like that, so many levels we can use it. The third is runtime. If I want to read the annotation values at runtime, you can provide at runtime. So we specify the example for runtime is at deprecator is an example of runtime annotation. Let's open at deprecator. See, it's available at runtime. Okay, these are all the examples. So what we decided in our bug report is we specify to available at runtime. Okay, so any question on this line? No. The next one is target. So where I can use this annotation either before the class or before the method, before the field, before as a parameter, whatever you want, that you can specify with element type. So when you click here element type, see the type may be to the field or method or parameter, constructor, local variable, even an annotation type before package or a parameter. So like that, you can specify what type of element you have. So that's what we capture here. So there are different types you can use it. Annotation type, constructor, field. So look at your code here. What in our own annotation we specify to the type means before the class. Before the class, you have to use this annotation. Okay, please take a look at the whole, how to define your own annotations. Okay. So if you look at everything, you must specify at target. If you want a multiple fields, you can use everything. So at nullable, also we specify at retention and at target. And deprecator, we put at retention. These are the two mandatory fields you need to give it. Okay. Now we are going to learn, we specify this is available at runtime, right? So how to process this annotation at runtime. So this knowledge is really important when you use a runtime dot class file. If you want to execute at runtime the values retry, this code will be useful to process your annotation at runtime. Okay. So do you have any question on this one? No questions, right? So then I have created a class called bad code. I want to add a number here. We do the subtraction. So this is a bug. So we put add bug report and assign to what are the values you have in the bug report. One is author, another one is severity. So no need of this argument. I mean open and close bracket. So simply give assign to, put your author name, severity is equal to. So this way you can make use of your annotation because we specify this is the target is before the method. When I use type means before the class name you have to use it. So that's what before the class name we put our own annotation. Any question on this line? Okay. Go to the more bad code. So we put a subtraction and inside that we addition. But I didn't pass any argument. So what will be your value in this case? Assign to is none. Sorry. Where is that? Okay. So it will take none. If you don't pass any or values, then it will take the integer value of 0. So any questions so far? Now we are going to write the code I want to retrieve these values, whatever I stored. I want to retrieve at runtime because I gave it. This is available at runtime. So you can go to your annotation info. Okay. So if I want to retrieve the runtime information about the class, so those are called as reflection libraries. You can get all the information at runtime about the class. So for that purpose, I need a object of bad code.class. So what is your bad code? This is the class you created, right? I want to get the information at runtime, so I can call bad code.class. So what is the return type is? Class type of bad code. Okay. Then you can check at runtime whether this code has annotation present. So I can call this class object dot is annotation present. So inside this file, you can have multiple annotation, but I want to check whether this annotation is present. Did you get the point? Because inside this, I have only one code, right? But you can have auto override, at suppress warning, so many annotation. So I would like to check whether this annotation is available or not. If it is exist, it will give you a Boolean value, right? If condition is true, I want to retrieve that annotation object. So here is your class file name dot get annotation, pass this annotation. If it is present, we are retrieve that annotation. Then you can call, this is your annotation object, right? So annotation type is bug report. So you can retrieve the values at runtime, whatever I assign. So for this bad code, what is the value we assign? Carosa and severity 1. These values you can retrieve at runtime. The same thing we did for the more bad code also. The code is same. Please take a look at this code. If you have any questions, let me know. So let me run this code. Okay, so this is your bug report. Annotation on bad code assigned by this author and severity is 1. But this one we didn't specify anything. The default value will come. So by this way, you can create your own annotation and you can retrieve the values at runtime. Any questions here? Okay, so that's all about your annotations. So there is an exercise to create your own annotation. So you can take a look at that part. Okay. 2 minutes stretch up. So many people are not go active. Do some stretch up for 2 minutes only, okay? 10:50, I'll give you a break. Before that, some stretch up. Okay, active. Okay, so 10 more minutes will continue, then we will take a break. Okay. So the next topic is about new Java 8 future of try with resources. Okay, that's what we are going to look at. Okay. Already you know that how to handle the exception, right? Try, catch, finally. What is the use of finally block? Closing. Close your resources, right? So we usually, when I do the try catch, so you usually give a finally block which is important to close your resource carefully, right? If you don't close your resources, that may cause a memory leak, right? Many times if you use it, your application might crash. So we need to save the resources, whatever you open a file or database, we have to close it properly, right? So that's what we need to provide a final block to clean up all your resources, right? So here we have some complication in this scenario. Okay, look at this code given here is, I'm going to open a file. Okay, so try to open this file through buffered reader. I'm going to reading after that. I'm going to read a line by line from the text file. Now what happens if the file does not exist? It will throw IO exception, right? So I hope you familiar with that. IO exception is a kind of checked exception, right? What do you mean by checked exception? It automatically inferred by the compiler, right? So when I use this buffer reading, you must give this line. If you don't give it as compiler force you to give that. Did you know that? That's called checked exceptions. So the checked exception means you must throws in a method. Those are all called checked. Another example of clone not supported. Exception right? Propagation, yes. Huh? Exception propagation. Propagation. What do you mean by? I mean, in stack, lowest have to. Yes, that has stack. Yes. So over here, you must provide this throws IO exception. If you don't give automatically, it will give you a compiler error. So it's called a checked exception. So I'm going to open a file by reading a line of text. So it may cause a IO exception. We are not handling it. So this exception is logged to review by the developers future. Then we are going to rethrow the exception. Okay. So caught the exception because it's a checked exception. You must use with try catch. Otherwise you will get a compilation error. So we caught this exception. So this is your regular process, right? So I open a file. If the file is not able to open, you will catch this IO exception. Inside the finally block, I'm going to try to close my resources, right? So if you have exception, it will go to this block. If you don't have exception, what will happen? It will come to your finally block. When I try to close my resource, you may have a chance to get an exception when you closing your resources, right? So how can I handle that situation? Provide another try catch inside finally, right? But usually we can catch one exception, right? The remaining will not be caught, right? So for that purpose, we have to do two different exceptions. In the one code, if I have multiple exception, any one will be caught. That's what we provide individual try block. For each exception, we need to catch it. Okay, this is your old approach, right? If I want to rectify this error, I need to provide another catch. Okay. Now, what is the problem here is, suppose if the developer forget to give a finally, sure you will get an exception, right? So that's what, there are some potential problem with this logic is, it's messy and easy to implement it incorrectly. What do you mean by incorrectly? Means you may forget to provide finally, right? And scenarios. So if the buffer reader is created and read line causes an IO exception from the main code, right? So if the file reader has error, it will throw this exception, right? So that's your next scenario. In the finally class, an attempt made to close the buffer reader that also can throw an exception, right? So only one exception can be thrown. The remaining will be does not caught, right? So we have to be care about it, this one. So for that purpose only we provided true try catch. So this is your problem. Now to overcome these issues, the Java 8 came up with a new feature called open with resources. So try whatever resource you open, put it inside the try method. So usually in the previous code, how your try block looks, just open a flower bracket and do the coding. Now, whatever resource you open, put it inside your try method. Okay, buffer reader I would like to open. So this is the one cause and exception. When I create a new file reader of file, I try to open a file F. This will cause IO exception. Put that block inside the try. This is called try with resources. You no need to provide finally because your try will handle the finally automatically. It will have auto closable interface. So it will handle it automatically, the closing resources. You no need to close the resources. Okay. So that's what, whatever resource you open, put it inside the try. It will automatically close it. Now, when I try to open a file, if I caught an exception, it will throw IO exception. If I don't get any exceptions, then automatically it will close it, right? If something during the closing time, if you find any exception, that's a new feature called get suppressed warning. We can retrieve the remaining exception as suppressed one. So here is your exception E. E dot get suppressed. One main exception, which is IO. Other than any exception comes, it will be retrieve as a suppressed and I'm going to print that. The main exception, do the log and the remaining as suppressed and we are going to print it on the console. Or you can print it on, store it on log to fix it later by the developers. So this is the new approach. We can use it. Take a look.
On method, we don't need now throwable.
Yes, yes. So because any type, right? The common type for all the exception is throwable, whether checked or unchecked.
No. I mean, handle file and the throw exception.
File throw. Yes. This line?
No, up.
Okay, this one.
Yeah, here we don't need now throw exception.
Yes, no need. So that's the advantage. So that's easily cut it without throws the exception name on the top. Okay. Any questions here? So that's the advantage. When I use a try, it will automatically close once your try block is over. So any exception comes, it will be captured as a suppressed exceptions. So that's the advantage of try with resource solution. So you might wonder what else I can inside use try block, right? So each methods, whatever resources, also you have a code with how to work with the setup connection, which we discussed already in the Java stream code, right? Optional dot off nullable of get connection with or else get. So that's the approach has produced here. So you might wonder what else I can use with try with resources. All those libraries. Whatever Java 8 library which implements auto closable, all those things you can use with try. Inside the try bracket, you can use it. I'll show you here. Let's open a buffered reader. Okay. Buffered reader extends from reader. When you see reader which implements closable, when I open closable which implements auto closable. So whatever which implements auto closable, whether it's parent, it will automatically applicable to use try with resources. So for that purpose, we have shown so many API libraries which implements auto closable. Okay. So before handling this, let's take a break for 10 minutes. 10:46, 56 we'll continue. Okay. 10 minutes from now. Okay, take 10 minutes break, guys. Online, guys.